by machine learning. So this is an example where machine learning was trusted too much. But also we see, if we look into the literature, words like black box are very highly correlated with words like neural network and much less correlated with words like Bayesian, maybe twice or three times as much, depending on how you measure it. Again, thank you, ADS. This is telling you that we're very anxious in the astronomy community, at least, about using machine learning techniques. But we still don't really know how to vet them because papers like the one I'm showing before were happily accepted by the community, even though they were quite wrong and used machine learning techniques incorrectly. So one thing we're doing at Space Telescope is trying to build verified trust in machine learning through this process, through this thing we're calling Hello Universe. So right now, Hello Universe consists of 4 large data products that are referee data products that have been in our collection. And then notebooks that show you how to work on those real problems with real data using machine learning, including neural networks, decision trees, k-means, all sorts of fun stuff. So we think this is an interesting solution for those kinds of problems, helping people build real trust in machine learning and understanding how to interrogate the problems and see where they may be failing. Okay, so I'm going to give you just a few take-homes. First, trust is a powerful lens to help us answer the question, why are we building this? Next, archives can be a powerful foe of no-guy science and enable scientific accessibility. Thirdly, community contributions of data, code, and notebooks can help turbocharge this trust, can help the community really move forward quickly in a way that makes scientific sense. And finally, machine learning is a necessary tool for the 2020s. And archives can bridge the gap in machine learning, that machine learning trust gap, and take us to the next step. And I'll stop there. Thank you.
Thank you very much, Josh. If you'd like to ask a question online, please raise your hand and Cindy will elevate you to a panelist. If you're in the room and like to ask a question, please come forward to one of the mics or raise your hand and we'll bring a mic to you. Well, Josh, let's see, do we have any hands online? All right, we will go with Rupesh, then David in the room.
Thanks, Josh. Lovely talk. So, in your opinion, could you tell us what role you see headquarters playing in this transformation that you've outlined for us? Thanks.
Ooh, that's a really hard and good question. I think headquarters has the opportunity to find the places of overlap. I think I certainly find myself, I have groups that work for me, trying to find the difference between places where it's convenient for things to work the same way from a accounting perspective or from a technical perspective, versus times when I can see the overlaps between these communities that really have an opportunity to blossom. One thing I didn't talk about is a small AI ML project in which we were basically trying to build a search by image system. And Manil, I don't know if you're on the call, Manil, but Manil basically provided a shotgun marriage between my group in Astro and a group called Space ML in Earth Science. And at first I was like, come on, man, I know what I'm doing. Like, I don't need you to make nice for me, like, whatever. But it was extremely fruitful. And there are really places, cross-disciplinary places, where there are opportunities to see those connections. I think, Rupesh, at your level, seeing where those connections exist across archives between, say, us and our sister archives within a discipline can also be extremely powerful. But it does take some spending time in the domain, spending time with community, and really being focused on community. That's sort of where I find the most juice, is when I say, where is the community right now? and where could they gain something valuable from other pieces of the discipline and other related disciplines. I hope that was at least partially helpful.
All right. David, and then do we have anyone online? All right.
Hey, Josh, this is David Charity. Thanks for the nice talk. I missed the very first 5 minutes of your talk. Apologies, so maybe you already covered this, but I wanted to get your comments on the word community in the sense of we are seeing a incredible uptick of citizen science contributions in a variety of disciplines. You know, my experience, of course, is exoplanets, but we see it across the spectrum in astrophysics and planetary and earth science, etc. And also, open science means that we're trying to reach those folks that are not, say, actively participating in professional projects as citizen scientists, but rather they're trying to do science, on their own. They may or may not have, some of the same resources. So my question to you is, I absolutely agree. We've had this long conversation about building trust in our communities, but how do you see the Venn diagram overlap of how you build trust in a professional community versus a citizen science community versus a community that's an overlap of those two communities? Thanks.
Yeah, that's a great question. I think you've really nailed it by focusing on community there, and that the trust really does depend on the way the community is structured. So I always make this reference to how planetary and astro folks, you'll see in the comments 6 minutes ago, how planetary and astro folks think about the relationship between data and refereeing and publications in a different way. And so the way trust is built in that context, even though, we're all studying planets, for instance, is quite different. And I think it's much more different in a citizen scientist context, because you have to meet those folks really where they are. And that's why I often, when I'm working on citizen science projects, lean on our friends, say at Galaxy Zoo, sorry, Zooniverse, who have really spent a lot of time with those communities, because that knowledge is extremely, you can't fake that, right? That knowledge is really, really valuable. And the structure of those communities is kind of the key thing. I think in those contexts, you're also building the structure of the community, right? The platform is what defines the community in some sense. And so you have lots of opportunities to figure out how to help them move in the right direction. I am not, one thing I always try to focus very hard on is things I'm not good at, and that is one of them. I'm not a specialist in those communities. So I think I would say that we need to be sensitive about our tooling, about our technology, about our data systems, and not just say, hey, I made a portal to the data. Go for it, citizen scientists, because that portal is going to be designed around the scientific community and how they exchange knowledge and how their culture functions. So we do need tooling that really works for that community, specific for that community to build mutual trust.
We have 2 online questions. We'll go with Rachel first and then Bhaskar.
Hi, I'm Rachel Connolly from MIT. My question is really just about, we talk about, growing public trust in science because of open science. And even the Pew report came up earlier this week multiple times about, how people are decreasing their trust in science. And I'm wondering about how this is going to bump up against, it's more complex. We're increasing the complexity exponentially, but we're also saying that, this is going to make it easier for people to trust. And I'm just wondering, it'd be great if we got involved with sociologists really early up front in this to sort of study this, how open science is really going to, I think, potentially even further hurt, in some cases, the public trust.
Right. I think one of the things we've learned from these platforms is that you can hide a lot, or you can show complexity while still giving people, the power to create the knowledge to run something. So it's not that hard to say, here's a tutorial, usually in the form of a notebook, that runs you through some things. And yeah, like, here's some lines that you're not going to understand. but you can touch it, right? You can change it, and you have that power of changing the system and seeing how it reacts. And a lot of way, at least for me, that I build trust is by poking something. When someone's giving a talk, if I can leave a message in the chat or raise my hand, I can poke at it and I can see how it responds, and so I can gain some trust. A paper is a flat object. A data set is a flat object. I know how to poke data, but the community does not know how to poke data. And so by giving people these live tools where they can kind of attack the question, I think there's a lot of value there. I did a bunch of work, oh my gosh, almost 10 years now, on what we call the paper of the future. The idea that a publication could have figures that can self-interrogate so that you can brush and in linked views, you can move sliders, you can explore. And then exploring, I think, gives people a lot more trust because they can say, this is silly, I don't believe this, and then they can poke at it and say, okay, well, maybe it is okay. So I like interactivity at various different levels as a way to build trust and sort of a lens through which we can talk about building trust.
Thanks. Bhaskar?
Thank you. Hi, Josh. My name is Bhaskar Ramachandran. I'm the LAD Stack project scientist at Goddard, and I'm the one who'd asked you this question about epistemological foundations in the chat. So as a follow-up, I just wanted to find out from you, do you sort of talk to or consult with anybody with a philosophical background? The reason being, I'm noticing that there's a ton of things to learn from philosophy of science and philosophy of sociology and technology, or rather the sociology of science and technology. And sort of going back, there are a bunch of philosophers from the 50s and 40s. The one that comes to mind is Bruno Latour, and there's another lady from Austria called Karen Norsetina. She compared, for instance, how two different communities, one the folks in studying physics versus microbiology, especially the CERN community versus microbiology, how they sort of work and interact and exchange and communicate. And I think a lot of that has implications for how we think about open science today. And so that's kind of what led me to sort of look at epistemological issues as far as how we ultimately manufacture knowledge, because ultimately it's a very individual sort of a derivation itself. So anyway, I'd love to get your thoughts on that.
That's super interesting. I think, like a lot of scientists, my understanding of these things ends with the structure of scientific revolutions. Um, uh, and I think that that's certainly a hole in my education. I've found that when I turn to these different disciplines where I'm absolutely a novice student, the places where I find the most juice, the most power is in ethnography and sociology. That's where people are answering the question not from a more abstract perspective, or at least I've seen so far, but rather from a practical perspective of how things are happening. So there are groups, for instance, I wish I could call up the names off the top of my head, who study how hack days work. What is actually happening in a hack day culturally? And so they've come to, I think they've come to the Space Telescope. They've certainly come to various hacks that I've been a part of, interviewing people, asking these questions, trying to understand how is work happening here? How is science happening here? This is the classic ethnography study of the Mars rover team. I think I'm really interested in bringing more people like that into our communities to ask the practical questions of how is this actually working? Like, what is the actual process? Because I'm showing you my bibliographic analysis, I'm showing you my intuition from being a practitioner, but you're absolutely right. I live inside myself. I haven't really done the work, and really what I'm good at is studying galaxies at redshift a quarter. So there should be some more professionals involved. So I'd love to be engaged with professionals who are really actively studying our culture and our cultures. Right? This is not one culture that we're in here. We're clearly quite distinct in this room from I don't know, business culture. But Planetary inner science and astro are not the same, and they do work in different ways, and our systems really need to be organized around the ways those communities work.
All right. Thank you very much, Josh. In the interest of time, we're going to move on. But hopefully the discussions can continue in the chat. I'm going to hand it over to Elena, who will be moderating the lightning session.
Okay. Okay, thanks, Steve. We're going to start with Emily Law.
That's one side.
All right, thank you. Good morning, everybody. Thank you for having me here. And I'm going to talk about JPL Open Data Repository. JPL is working on open data, open repository, and open science. We have developed a data and analytics strategies that promotes openness and also drives capability in the capture, management, and use of open data and analytics. In support of that strategy, we have stood up a FAIR data system that we call the JPL Open Data Repository. We have applied trust principle that Jeannie Banky talked about the other day, and we are meeting the trusted data repository requirements defined by the core trust sealed assessment process. The artifacts that we host include raw to analytic ready data sets, documentation, publications, software, and models. We have the ability to create and tag DOIs on artifacts that does not already have one. Building on the open source Harvard Dataverse, we have developed a capability leveraging technologies such as semantics and NLP to link the data, the publication, and the software together. For example, let's say you are a researcher looking for a publication. Our search result would include the paper that you'd want, along with also the data and also the code that's referenced in the paper, as well as relevant to your research. With a single click, you would be able to initiate a runtime environment to run the code against the data sets in the paper to reproduce the analysis results cited in the paper. You can also use different data sets that's relevant to run with the software, or use different softwares to run with the data sets cited in the paper. So that is how, that is just actually one of the many use cases in how we support open science and also enable and also advanced discovery. So if you are interested in learning more about the repository or what we do at JPL, please feel free to contact me. Thank you.
Thank you so much, Emily. So next we have Marshall. Marshall, I'm sorry, how do I pronounce your last name? Stachinsky. I know your pain.
Hi, I'm Marshall Stachinsky, and I'm a postdoc at JPL. And if you have any questions about things that you're seeing today, you can contact me at my email at the bottom right here. So a little bit of a shift from the kind of main focus of a lot of what we've been seeing so far. I'll just be telling you about a use case where I have open source software that I've created in the course of my research and have augmented other projects. So I work on magnetic sounding, so taking magnetic measurements from spacecraft and learning about the interior structure of icy moons. And all three of the repositories that I'll be talking you through briefly here are in service of that goal. So the three that I've been working on in this order are Planet Mag, Planet Profile, and Moon Mag. Uh-oh, are we muted?
We need to share the screen.
Oh.
I'm so sorry.
My words still count though, right?
Yes, of course.
You'll see the pretty pictures in a moment.
Okay.
Yeah, no problem. So the three repositories, the main ones that I've been working with are Planet Mag, Planet Profile, and Moon Mag. I know, very creative names, but we brainstormed for a long time trying to come up with ones that would fit. So on the left, Planet Mag is trying to evaluate planetary magnetic field models based on best fits from the literature. And the main goal of this is not just to evaluate the field at the location of spacecraft for that being a utility, but also to evaluate how magnetic fields oscillate at moons, because this is an important feed-in for forward modeling of magnetic sounding. And Planet Profile is geophysical models that take bulk inputs like the total mass and axial moment of inertia and surface temperature, things like that, and then evaluate a radial interior structure profile. And this is an important feed-in along with magnetic oscillations to the third repository, which is Moon Mag. And I created this for my PhD research that I finished last year. And it's forward modeling of magnetic induction for icy moons. So all of these three projects together give an end-to-end pipeline, basically, of what are magnetic fields expected and what is interior structure possibilities for moons, and to be able to compare magnetic field forward models against spacecraft data. And the Planet Mag repository is in progress. That's something that hasn't been released yet. But Planet Profile and Moon Mag are both accessible through the NASA-planetary-science GitHub organization page. But this is what I'm working on, and if you have more questions, please just contact me on my email. Thanks.
Thank you so much, Marshall. Okay, next up we have Shri Vinay with CDAC.
Hi, good morning, everyone. So I'm going to talk about the NASA Socioeconomic Data and Application Center, CDAC for short, and how we are supporting the goals and the activities in the open source science, in support of open source science. So just a little bit intro about CDAC. Many of you might be wondering, what is social science happening, why social science is happening in the earth science arena. But what we do is develop data sets that have how humans are impacting the environment, and vice versa, how the environment is impacting the humans. So it's the human dimensions discipline. And we integrate earth science data sets and social science data sets and make them available for researchers in both disciplines in easy to use formats. So that's, in brief, that's what CDAC is. And I serve as the system engineer at CDAC. So I think I'm preaching to the choir here, but our goals and principles align with the open source goals that we all have been talking about this whole week. And they also align with the World Data System of which the 12 earth science DAGs, including CDAG, are part of WDS in short. So we aim to provide universal and equitable, full and open access to quality assured socioeconomic data sets related to EJ and CJ, environmental justice and climate justice. And enable and support long-term data stewardship. What that means is we do long-term archiving according to all open standards, archival standards, and in the whole Estes ecosystem, following the same guidelines and principles. So provide metadata about the provenance of the data sets, quality of the data sets, and so on. So it can be easily reproduced, or users can track the quality of data, where they come from, and so on, and the trustworthiness of the data. Foster compliance with data standards. These are open data standards and conventions from the social, natural, and health science disciplines and other application areas. So, for example, a small example is we support all the OGC standards like the WMS, WFS, WCS, and so on, and make most of our data sets available in those standards to users and applications, and provide mechanisms to facilitate and improve access to and use of data. So making the data set available in the trusted repositories, documentation, and so on. So in what areas or disciplines our data sets help users? So there are about 50 scientific thematic areas that CDAC has data sets on, including population, infrastructure, indicators related to poverty and sustainability, climate, and so on. So about 15 scientific themes, thematic areas we develop data sets on. Many of these data sets, like I said before, integrate satellite data with social science data, demographic data, population data, and so on. And we also develop web tools, even mobile apps, and open standard services and resources, including almost publication quality documentation. Even though they are not published, they are very detailed and thorough documentation available to users easily, and other knowledge and information products that help in the application of the data. We do have a citation database that is linked to each data set. So all publications that we can find that reference the data are linked in our database. So users can search the citation database and look at the publications that uses the data that they are interested in, and that helps them determine whether that data set is applicable to their area, their interest. And provide all this to make the data development process, the process we follow in developing the data, open, transparent, and reproducible, including the code used for developing the data and sample code for analyzing the data, like Python, notebooks, all that stuff. We make them available through GitHub or GitLab or whatever. So what are the challenges we face? Some of the input data sets that we use in integrating and developing the output data are licensed. For example, some census data from certain countries are licensed, and we cannot distribute them to users. We can use them, create the new product, and make them available, but the input data itself cannot be distributed. So that is an impediment to reproducibility. And another obstacle maybe is sometimes you need a lot of compute power and compute resources to reproduce the data sets. So moving to the cloud may be helpful in that sense. But to redevelop some of our data sets, you're going to need lots of compute resources. So that's another challenge that we have to overcome. Stop there. Thank you.
Thank you so much, Vinay. Next, we have Joe Mazzarella, who is online, who's virtual, I believe. Joe, could you come off mute and
Yes. Are you going to display the slide?
yes, yes.
Okay, great. Can you hear me okay?
Yes, we can. We can hear you very well.
Okay.
So, apologies for the delay. We'll have the slides up momentarily.
All right.
Okay, go ahead.
Oh, great. Good day, everyone. Thank you for the opportunity to speak briefly. I'm Joe Mazzarella, Science Lead of the NASA IPAC Extragalactic Database, NED. I want to share with you a recent development that should be of wide interest among the open science community. The NED team has recently led a broad-based international collaboration to publish a journal article titled Best Practices for Data Publication in the Astronomical Literature. This appeared recently in the Astrophysical Journal supplements. The article is by Chen et al. And includes co-authors from all the NASA astrophysics archives and the journal publishers shown here on the right. The article provides guidance for presenting data and metadata in the astrophysics literature. It addresses important open science and FAIR principles of findability, accessibility, interoperability, and reuse that we're familiar with. The paper is intended primarily for authors, referees, and editors to reference during manuscript preparation, peer review, and publication. Of course, we encourage everyone publishing results in astronomy to read the entire article, but it also provides a very convenient checklist covering highlights of the main topics with links into the details in the paper. And these include, general guidelines, nomenclature, astrometry, photometry, time domain information, redshift velocities, classifications, orbital parameters, preparing tables and figures, data archiving and access issues, literature citations and facility credits, and also providing proper credits for software and DOIs and data content keywords. We're also excited that this best practices article has already been linked to in the instructions for authors at these major journals. The AAS journals, including the APJ, the APJ letters, supplements, and the Astronomical Journal, and the publications of the Astronomical Society of the Pacific, and also monthly notices. So the main takeaway here is that following these best practices will improve the scientific record in the literature, enhance the reusability of data, and help streamline ingest into the archives accurately and efficiently to facilitate NASA's open science goals. That's it.
Thank you so much, Joe. Next,
Sure.
we have Thomas Bristow, and I believe Thomas. Oh, did that not come through, or?
That didn't come through for me. Can you hear me okay?
Yes, we can hear you.
Okay.
Okay, we're sharing your slides.
Thank you.
One moment.
I can just start. My name is Thomas Bristow. I'm a scientist at NASA Ames Research Center, and I'm the project scientist of a repository called the Astrobiology and Habitable Environments Database, which is known as AHEAD for short. So I wanted to talk about today an open science framework for long-tail research data. Many of the advances in astrobiology are driven what I'll refer to here as long-tail research. And by that, I mean research performed by individual PIs and small teams, producing what are often highly diverse but relatively small data sets that span a variety of traditional scientific disciplines. So AHEAD was designed with the needs of astrobiologists as a focus, but long-tail research is important in many areas of planetary science and other S&D divisions and the research and work that they do. And on the second day of this workshop, one of the breakout sessions asked how more of this type of data can be captured and made open rather than ending up on a dusty laptop. So here I wanted to take the opportunity to draw your attention to the tools and approach that we've taken in developing AHEAD, because we think this strategy is adaptable to areas beyond astrobiology. So a key part of the AHEAD system is the Open Data Repository Publishing Platform. This is an open source software designed around the needs of long-tail researchers. It's been designed to lower barriers to online publication of datasets and supports an array of data types and formats with no need for users to write code to publish their data and datasets. We like to liken it to the WordPress for data. In the AHEAD system, the ODR publisher has been linked to an astrobiology-focused portal, which features a variety of search tools to cater to a wide audience. And the portal also hosts a step-by-step dataset creation wizard to streamline the publishing process and ensure datasets conform to our metadata standard, the Astrobiology Resource Metadata Standard. So I've gone through that very quickly, but what I hope that you'll remember from this presentation is that we think AHEAD provides a template of how what could be core services for long-tail data can be combined with discipline-specific interfaces, tools, and metadata. So in other words, this approach demonstrates how the efficiencies of core services could be realized while retaining data handling expertise and the trust of communities from different disciplines. So thank you.
Thank you so much, Thomas. And now we're wondering if Sunny Narayan is online. Yes. We're not sure if he's online. But if can you come off mute, Sunny, if you're online? Or raise your hand. Yeah. So in that case, if Sunny is not online, I think we'll go to Emily Law's second presentation.
Yeah, do you want to do it? Okay.
Okay.
Sure.
That's great. Yeah. Thank you. Thank you, Christian.
Yeah. This look great.
Thank you, Emily.
Thanks. Still not this. Thank you for being patient online.
Yeah. I'll just get started anyway. Emily Law from JPL again. Thank you for this opportunity. So this is actually, related to my first talk about JPL Open Data Repository. So it's kind of like a follow-on. I'm introducing this solar system track, which is a project that we believe is also a fair data systems and also is a trusted repository to support open science. So what is Solar System Tracks, which is really provides a set of web-based portals with interactive visualization and analysis tools enabling scientific research, mission planning, education, and public engagement. So we already have 11 portals publicly available. If you just go to type track.nasa.gov on your browser, it will take you to our homepage that allow you to be able to explore 11 different distant worlds, looking at their exploring and studying the amazing landforms that they have. So the repository hosts numerous geospatial data products that are already visualization and also analytic ready. And we also have a wide range of analysis tools, such as machine learning feature detections that using deep learning algorithms. is actually a part of the planetary data ecosystem and also an infrastructure component for the science activation program. We also have an open source data pipeline that can generate digital elevation map and also mosaics. So as I mentioned that, it's a fair data system with a really intuitive user front end, and then serving up as a trusted repository in the back ends. So from the very beginning of the project, we aimed at providing an innovative geospatial platform that make the data easy to access, to interpret the data, as well as to use it. So our plan is to enhance the system to leverage the JPL Open Data Repository's concept, as well as technologies to connect the data, the publication, and the software together. It's actually very doable. We are in really good position because the teams working on Solar System Track are the ones that are also working on the JPL Open Repository. Okay, thank you for listening.
How about we take a 5-minute break, and after the 5-minute break, we'll have the other talks that we haven't seen already, and then we'll resume with the schedule. Push the button, okay. Welcome back, everyone. We're gathering back together in the room. And those of you online, thank you for your patience as we get the presentation up and get everybody back together. So we have two more lightning talks. The next one will be Matt Tiscarino. And metadata heterogeneity.
Cindy, can you see it?
All right, thank you very much. My name is Matt Tiscarino, and I'm the manager of the PDS Ring Moon Systems node at the SETI Institute in California. And I just, I put together this slide before the meeting, of course, and some of these things we've talked about, but I just want to emphasize one last time some of the challenges of bringing together disparate kinds of data as is part of the Open Science Initiative. If you think about, astrophysics data and heliophysics data and earth science data, they're all very different from each other. And finding a single way to reference all of them together is a big challenge that Kaylin and her team have been starting to tackle. But I just want to partly point out that planetary science is already very diverse within itself, and PDS has been dealing with this problem for 30 years. Metadata is hard to integrate across science disciplines. One of the ways that PDS has been doing this is using different solutions for different science disciplines. We've been, for the past decade plus, have been working on the PDS-4 information model, which is a very rigorous way to take all of our disparate data and reference it in a common way. But in doing that, we've been confronted with how disparate it is. There was an exercise once where people who are architects of the information model came together and said, let's find something like 10 attributes that are going to be common across all of the data sets in our archive. And they worked at that. Oh, here's one, not really. Here's one, not really. They come up with start time and stop time, but even that had to be nillable. Because there's just so much diversity and disparity in the data. So the solution that PDS has settled on is to have discipline-focused search tools that the different discipline nodes host, and then looking for ways to tie them together. So there's a tool that's the best tool if you want to search for maps. There's a different search tool, which is what one at least best search tool for remote sensing observations that can't be mapped. For that, I would recommend you Google PDS Opus, OPUS, the Outer Planet Unified Search. There's yet a different way to search for data that's in situ. So it's important not necessarily to have one tool to rule them all, but to guide users to the tool that's best for them. I know my last brief point is that oftentimes there's the idea that text search is the best solution for everybody. Why can't we all just be like Google? But there's actually reasons why we can't all just be like Google. And for many applications, faceted search, which is what Opus uses, is in some cases much more effective. I'll just stop there.
Thank you so much, Matt. And last but not least, we have Brianna Pagan. And thank you for your patience while we put the slides up. It's a process.
Awesome, thanks. Yeah, Brianna Pagan again from the Goddard DAC. So this is going to be pretty brief. We just wanted to touch on different initiatives that we're working on at JESDISC. So first, we are having a representative involved in TOPS, and we have active collaborations with OpenScapes community. We have 3 different mentors right now actively participating in OpenScapes. You saw Alexis co-present also earlier this week. We're also in the middle of migrating all of our tutorials to the NASA GitHub, and we're committed on any future software that we're creating to actually develop it in GitHub and in the NASA GitHub community. We're also really committed to developing in open source software. So you saw the demo earlier this week with Pangeo Forge. We're also actively using Czar data as a format, and we're contributing to the new Czar spec. I really recommend anyone who's using these types of data formats to contact those organizations and see how you can get involved and give your feedback on using those. We also are collaborating with other DACs to produce GIS web maps, story maps. We will be participating in the algorithm publication tool, APT, which aims to standardize the algorithm theoretical basis documents and provide collaborative platforms to move new data providers to the open environment. And we're also going to be actively involved in MAP and developing our services to be compatible within the MAP ecosystem. And we look forward to encouraging also our own staff to take part in the TOPS training. That's it. Thank you.
Thank you so much, Brianna, and thank you to all of our Lightning Talk speakers. If anybody in the audience or online, in the online audience, has questions for the speakers, we are going to be posting the names of the speakers in the agenda. And please feel free to contact the speakers with questions or approach them. So next we're going to be doing, well, it's not really a breakout session because we're not breaking out anywhere. It's going to be everybody in the same room. But we are going to be doing a discussion on what the future of data repositories looks like and what that looks like to you from your perspective. And so we invite questions and discussion from the in-person and online audience on that question of the future of data repositories. So is there anyone who'd like to start? I see Joshua has a hand up online.
Hi. I'll just pop in with some interesting future thoughts, which is freeing ourselves from thinking about basically having open text search fields be something that's easier to do and to explore. The change in the way NLP, natural language processing, has happened over the last even 2 years is truly extraordinary. I mean, we are just in an absolutely different world in terms of how computers can interpret words. And thinking about how those map onto our databases and map onto our explorations, I think is something we really need to be experimenting with. Just being able to say, I'm interested in all the papers about dust that use this. That could be a future we live in very, very soon. So I think being abreast of those things is important.
Thanks, Joshua. Oh my goodness. Okay, is there anyone who would like to respond or bring up something else? Looked like Brian, you had a question. Yeah, of course.
Fantastic. So the last session was super interesting. So I want to thank all the speakers, but my tiny mind immediately latched onto a few things, and one that I'm super curious about at this very instance is the minting of DOIs by users. I think this is a really enabling approach. It's also highly problematic, and some people have already raised some questions in the chat there. I'll just, I think this could easily be an hour-long or more discussion. So I realized in the chat somebody was going to point me to more technical people, but I just wanted to get the author's thoughts. I know Emily, your archive, and maybe a few others that I missed are enabling this, and I'm wondering what are sort of the lessons learned at a high level that you've learned. For example, minting a DOI for a user. There, I'm assuming this is down at the file level, right, from various missions. So, and when those data change, as somebody pointed out, what happens to the DOI? So I'll stop there because I could easily keep asking questions about this for quite a while.
Emily Lau from JPL. There is a lot of lesson learned we can from minting DOI. So, you know, we connect with data sites, right? And we mint DOI not just for data set, not just for files. You can mint it for a bundle of the data, you know, a collection of data, or a single data file. So it's all depending on how you want to use the DOI. And also, you can tag the DOI for software, and also, you know, for documentations, right? So it's just not just about data sets as well. I think in order for us to be able to, DOI is a great thing for us to connect all those pieces together and preserving them. And in terms of changing of the data sets, we have different versioning. So you would be able to put DOI for different versions as well if you need to. So yeah, so we've gone through a process to set ourselves up and connect the system, you know, to be able to mint the DOI. So if you're interested in that, just send me an email. I'll connect you to the developer. Okay? Yes. All right. Thank you.
Can I follow up on that?
Sure, yeah. So I think what we can do is take follow-up questions in the room, and then there are a bunch of questions in the chat. So
Is this on? Hello? Yep. So I put a paper in the chat, Brian, the Rauber et al. Paper that lays out the details of a recommendation that came out of the Research Data Alliance on citing dynamic data sets. So, and in a nutshell, it's careful versioning, timestamping, and then putting a DOI on the query, if that makes sense. And but that paper has like a dozen case studies of organizations that have implemented this. And it would be good if Josh followed up on this, because I know Josh has some issues with this recommendation, but my interpretation is essentially what MAST is doing.
Thank you. Josh, would you like to follow up on that?
Josh.
Oh, that
Yeah,
Josh.
So MAST has been doing this for many years now. We've seen really good uptake. It's now a thing that all JWST observations are doing, all publications. So we give people an interface that can select what they want out of our data sets and publish them. We're very focused on the user community and their needs. We try to avoid purity as a guiding principle. And so from that perspective, this question, the HST data, for instance, get reprocessed over time. We think of these DOIs as pointing at the observations themselves from a conceptual perspective, and the artifacts that represent those are the data as they're currently reprocessed. The raw data are also pointed to; those do not change, so that's pretty consistent. I guess what I'd say, I'm told that Chandra Data Archive, at least at one point, kept all of their reprocessings, and there was a point in time when the number of times those reprocessings had been asked for was this number, 0. And then I think it went up to 1. We don't keep those data. We literally do not have them. We know that our community does not need them or want them. And we don't think that any results, scientific results, will change significantly based on the reprocessing. Maybe you'll get slightly different error bars or whatever, things are slightly better. But qualitatively, in general, the results don't change. So we decided, we had a very long conversation about this in 2016. And we decided not to prioritize that. I think a really big question, which I find very interesting, is queries. How do we deal with a SQL query or equivalent? SQL is not an archival language. A query executed in one version won't necessarily return you the same thing. I think those are very interesting questions. We don't have a solution for that. I know there are astronomy groups that are interested in that. And that changes depending on what kind of thing you're querying. Are you querying a fixed data set that has data releases, or are you querying something that's fully dynamic? So I'm very curious about people's thoughts on that one in particular, because I think that problem is quite hard, and the results of the query can qualitatively change, not just change the bitwise level.
Thank you, Josh. Oh, and just if everybody speaking in the room could identify themselves.
Hi, this is Joshua Pepper from NASA headquarters in APD. So what I wanted to ask about is we've been talking about a whole new set of ways of accessing and querying data. And what I'm curious about is, since we've got such a broad range of scientific communities who are currently actively using the data and that we want to get to the data, how, from the repository's perspective, you all have, I think, user panels or user groups that advise you on how the users see changes or updates that you're making. For all of these things that we're seeing about open science, how have your user panels communicated to you about whether they think that these changes, these updates, are useful for both the existing users and for the and for new users? Basically, are we at risk of breaking working systems in the service of expanding them? And I just want to see what the general sense of from the repositories, what they think about that.
Thank you. Are there any responses online? Please feel free to unmute yourself or in the room. Jeannie.
So I'll take that question. I'm Jean Benke. I'm from the ESDIS project, which is the manager of all the DACs and processing systems within EOS DIS. And so in our case, yes, it was decided, before the 2000s that each DAC itself would have a user working group. And we take them very seriously. And each DAC will have telecons and then now Teams meetings and then face-to-face meetings. And we trot out what the DAC's been doing, where the DAC wants to make changes, and we take that feedback and write up action items during that year and trying to approach them. And then as the project, we collect all the minutes from the UWGs and then we review them as a group. So yes, we had a oceanographer meeting at JPL PODAC. Those guys, the science users that were selected for by headquarters principally and by our office to be the UWG, they don't much like the cloud. They don't much like the fact that PODAC is moving things to the cloud. So we have to take their advice and figure out, okay, what is the underlying message here? What are they really telling us? And so there are very positive comments. There will also be negative comments. And we have to take them both seriously. And it's incredibly valuable. Do we have anyone from a DAC who wants to add?
Oh, Yeah, if you'd like to add something, please come to the mic. And there's also, looks like a hand up in the virtually. So go ahead and then we can.
Yeah, this is Mo Kayat from the Goddard DAC. Just to underscore Jeannie's point, we actually are doing our UWG right now, and all of that, the feedback is something that we are currently right now in a separate meeting our guys are going through, and that's partially why we are splitting ourselves in this meeting and the UWG, our UWG. So
Thank you. So Raphael, would you like to come off mute?
Yeah, can you hear me?
Yes.
Okay, so I am Raffaele D'Abrusco and I work at the Chandra X-Ray Center. And I wanted just to expand on what Josh has said. We had two actually requests for older reprocessed data over the mission, the lifetime of the mission, more than 23 years at this point. And one of this came from a group at another institution that is interested in processing. So it was not really a scientific question. I also want to add something about our way of looking at DOIs. DOIs are attached to conceptual observations or conceptual units that we deem to be independent and granular enough to provide to be cited in order to allow reproducibility of scientific results. So, for example, in the Chandra world, single sources in the catalog are not worth DOIs. The catalog as a whole is a DOI. Single observations, each one have their DOIs. Stacked observation are conceptually different data entities that deserve a DOI, but not single detection in different observations of the same source. So let's put it this way: the DOIs had us thinking about our world long and deep, and we had to understand what we wanted users to cite in the papers to allow reproducibility of scientific results. So it was also kind of self-reflection on the nature of the data holdings that we provide. Thanks.
Thank you. Looks like we also have a hand up from Bruce Wilson in the chat. Bruce, can you come off mute?
I hope so. Can you hear me?
Yes.
Great. So my comment is that there's a tension between DOIs for credit, where the science teams have wanted us to maintain the same DOI so that essentially the citation count keeps going up, and the DOI more for the reproducibility. We had a lot of discussion about that over a couple of UWG meetings, and particularly because of the way airborne data works with often fairly frequent reprocessing. The consensus of our UWG for our particular domain was to push more towards the DOI for reproducibility, and then to work with some of the evolving methods to help to get the total citations essentially for a series of DOIs to represent, for example, the ATOM merge data product, which I think we're up to like 5 or 6 DOIs for that. So yes, it's a complicated problem, and it's which set of trade-offs does one want to take? Thanks.
Thanks, Bruce. Is there anyone who would like to respond online or in person? Oh, yeah. Go ahead.
Hi, this is Alberto Comazzi with ADS. We faced a similar issue when we started indexing software records, and the decision was made that we would index individual software products. So a new release does generate a new DOI through the GitHub and Zenodo integration. And we also find out that a lot of scientists actually are not crazy about this because, sure, this ensures reproducibility so that people can actually cite the individual release of a software product, but they want to see, a unified representation of the software in our system, and they would also like to see the citation count be a single number, for obvious reasons. At the same time, for papers, we have always followed a different approach where an ePrint on archive.org that then becomes a published paper is merged as a single entry in our system, and citation and usage is aggregated in that case. The rationale in that case being that the ePrint is really a preprint, so it's work in progress that then matures in a publication. So you kind of use that as representing the entire work, whereas with software, changes from one version to the other can be significant. But I'm just pointing out that we're not making everybody happy. We're making some people happy sometimes.
Thank you. And that's a great point. Oh, David.
Hey, this is David Chardy from Caltech and IPAC. I just want to steer a little bit on Josh Pepper's question. That sort of all the answers steered around the DOIs, but I just want to point out that in general, as we move forward, we don't want to break our services. We have international communities. We have long-standing, standards and things, and so we have to be very careful how we move forward in general, not to break our services. If they evolve and we break them, it needs to be broken in a structured way that we understand, okay, we are moving. So for example, the Exoplanet Archive just went underneath a entire revamp where we rebuilt completely underneath, right? And if we had just done that and then turned on the new service without educating our community about doing that, we would have been lynched, right? And so as we move forward over the next few years, I think, and whatever decisions headquarters makes about how all of these services have to work with these core services or not, we have to be really cognizant of, we have long established communities, and we're trying to grow our community, not break our services. Anyway, thank you. That's a soapbox that I'm going to hurt myself on.
Okay, is there anyone online who would like to make a comment? I just want to make sure we're not missing anyone before Brian. I don't see any hands. Are there any questions in the chat? There's a lot. Okay, sorry. I can only see this little tiny. So, okay. Yeah. Oh, there it goes. Okay. So does anyone from the chat want to come off of mute and say something about this? If you do, you can raise your hand. Oh, go ahead. Please go ahead.
I guess I'll just say something that I said in the chat, but I think this is a really great conversation because it really sharpens a key point of how we're going to move forward. There exists a fundamental tension between NASA uniformity and domain uniformity. I am an enormous fan of this overall push that we're seeing at the SMT level. I think all of the ideas, all of the fundamental motivators are absolutely the right thing. And this is how I'd love to see science structured in the future. And it may be that, reprocessed data in one context really makes sense to have separate DOIs because that's the way the culture is structured. And in some other sense, it doesn't make any sense because Chandra has only been asked one time for unreprocessed data. And seriously, we're going to store, you really want to spend the money on that? Those are right. And that shatters down, or that goes down to, ADS having to make different choices about these different data sets. And that's difficult. And I think a challenge for SMT leadership here is figuring out when it's, hey, your cultural tradition within your community is just kind of bad and we want to help you fix it. Like, if your tradition is the only way you're allowed to get data is by asking someone nicely, like this is a problem. That is not open science and that's not something NASA should bend on. But some of these issues maybe are places where we should respect the way the communities are structured. So I think that is going to be a fundamental challenge to this process moving forward. Not one I think we can meet, but definitely something we always must consider.
Thanks, Josh. Go ahead, Brian.
Hi, Brian Thomas and Heliophysics again. So I agree with you, Josh, and I think that there's another axis here, orthogonal axis, in how this is really pushing the system, and that's the DOI publication system is built around originally a concept of static documents, static data, and the reprocessing of the data, it seems like we're kind of fumbling towards a general solution, and that's great, but then what about services, and in particular, it's been brought up in the chat about queries and things that'll be dynamic, highly dynamic over time. And so I think it's clear there's a tension between the desires of open science, reproducibility, and transparency, which I also fully am behind, our infrastructure as it's currently built and the publication mechanisms. And I ponder that DOIs may not be the right citation mechanism for these dynamic things. And I would like to call, as I did in the chat, for our Office of the Chief Science Data Officer to consider creating a summit around the DOI issue and bringing the community together to discuss these issues. Because as was just mentioned by Josh and others, it would be highly desirable for us to, and I can't believe I'm saying this, have some kind of best practice around DOIs that we're generally all following as a community, because as we look to try to sew more of our data together between the repositories, between the domains, if we have inconsistent DOI publication practices, that's going to cause a headache and a big problem. And these dynamic services, and I can keep thinking of issues around this. So I think this is a real pressure point for enabling open science. Thank you.
Thanks, Brian. So I'm going to, I think now that we have you folks lined up to speak, I think what we'll do is we'll alternate between virtual and in person. So is there anyone virtually who would like to comment and respond?
Hi, this is Xiaohua from NASA Justice. So following the talk about DOI, so I'm wondering, like under open science policy, like we encourage research also open their data. So does it mean like they also have permission to register DOI? And I'm wondering, like a data repository will help research to archive their data. So in that case, what's the selection criteria and how to leverage our limited resources? Yeah, that's all. Thank you.
Thank you. Jeannie, did you want to respond?
Yeah, actually, getting back to the
by the
DOI
way,
discussion.
GD Benke, just so they know who you are.
Oh, yeah.
Yeah, sorry.
You did introduce me. This is Jean Benke from ESDIS Earth Science again. In the discussion of DOIs, I think one of the DAC people, I think there's 100 people online, could post the public wiki page we have on how Earth Science does DOIs. So we've been doing DOIs for, over 10 years and have a uniform application across all the DACs on how we want to see our DOIs applied. And so that is fully documented there. And so, maybe I saw a whole bunch of DAC people on here. Amanda, even Bruce, you could put up the wiki page from Earth Science. One of the things, though, getting back to a discussion of the future, one of the things I would like to see is that we never are in the position that we are right now with the ESDIS project in particular, where the Federal Records Center is sending back all the data that was pushed out there by Goddard 40 years ago. So we have tons of old media and all kinds of old stuff coming back that we then have to spend a lot of manual resources to recover. I think it's important for us to think 40 years in the future and make sure that what we're doing today doesn't require the same work that, I don't want my kids having to open up boxes and look at tapes and say, wow, is this a copy of Hickam? Or is this the original Hickam? Or what is this? And, back then we thought we were documenting everything really well at the NSSDC, but it turns out we weren't. So let's not do that to our kids.
Great point, Jeannie. So let me just go back to online. Since we have so many people online, I want to make sure it's, and does anyone want to come off mute? Okay, please go ahead.
I want to talk about something that has nothing to do with DOIs.
Yeah, that's okay. But just
I'll introduce myself
yes, please.
Please. I don't know if I should wait.
The floor is. Oh. Yeah. Okay. Thank you.
Okay.
Yeah.
Mark Parsons, University of Alabama, Huntsville. this seems like a very appropriate time to reemphasize, I put it in the chat, that we have our first guideline request for comment out on implementation of DOIs at NASA. So please go to that. The link is in the chat. And it also includes lots of references at the end, including the document that Jeannie mentioned, and some other guidelines that have been produced by NASA centers and others. I would strongly support a persistent identifier summit rather than a DOI summit. DOI is only one persistent identifier, and it is very much built around a publication model. It's called PIDapalooza. Yeah, there's a whole conference on this if you really want to get into it. But I mean, in terms of thinking about this across NASA, and I'd just like to double down on Brian's point that I think it was Brian's point that the publication metaphor, thinking of papers, doesn't really work for data.
Thank you so much. Okay, on to the next topic.
Ready. Matt Tiscarino, PDS Rig Moon Systems node. I really like what some people, Josh Peak and others, have been saying about trying to get away from I know a guy type science. That's really important, and I love the concept of it. If we want that to be realistic, a real key to that is documentation and user services. And that is something that our team spends a lot of time working on, and that includes getting data providers to write documentation. And if you want them to do that, NASA needs to back us up and provide funding and maybe even provide contractual obligations for them to do that. In addition to that, we at PDS write supplemental information pages that are part of our website. You know, if you want to know all about the Cassini data set or about the Voyager data set, we have extensive information pages. And that's also really important. In addition, sometimes people ask us questions and say, I'm having this problem with Voyager data. What do I do about it? And we answer those questions. So I just want to throw that out there, and I want to ask, does SMD have a plan for funding and encouraging that kind of work across the board?
Steve, do you want to speak to this?
That's always a good question. And I think, you know, this is actually one of the things to take a look at from here about, you know, what different mechanisms we can set up to help support that type of work and activity. Because I do think both increasing our documentation, I think also things like making our documentation more accessible are actually really important things. And what the right mechanism, whether it's direct funding from the divisions to their individual repositories, or whether or not it's a kind of separate mechanism, will probably be things we'll have to look at further. So I wish I had, other than to say that yes, we would like to support this and provide support for it, but we will have to figure out what the right mechanism is. Yeah, the question was, is the chat being captured? And I believe, so yes, the chat ends up getting saved as part of the minutes of the meeting. We're also recording the sessions. So you can also go back and review the conversations.
Thanks, Steve. All right, are there any comments from the online folks? Oh, Josh, okay. Can you come off of mute?
I can. I don't want to keep dominating conversation, so please hop in before me if you'd like. But I just wanted to say that we are finding so far that notebooks are an incredibly powerful way to document anything that can be interacted with programmatically, data, software, APIs, etc. It really, because it exists as a static document, it's powerful in that way, but it also can be downloaded and run, and then it also can be run on Binder or a platform or what have you. Giving people the ability to touch the documentation is really important. And critically, running it every night or running it whenever it's changed means that you're testing it. A problem with documentation is stale documentation. You don't know when your documentation has gone stale unless you have some very elaborate system. This is a computational system we can grab hold onto. We're not done building our system out. There's cultural aspects, there's social aspects, there's compute aspects, there's lots of aspects of it. But if other people are interested in talking more about notebooks under continuous integration, I'd love to talk about that with anyone who's interested, especially as a way towards more complete and reproducible documentation.
Thank you. Anybody in the audience? In the in-person audience, everybody is the audience.
Hi, this is Josh Pepper again from NASA HQ and APD. One thought I had that was raised, I think, near the beginning of the meeting by Brianna was that we probably are talking about things at a huge range of conceptual scales, from very high level to very low level. And I don't know if we've had enough feedback from people who are getting their hands dirty as developers in the individual repositories and in the community about these broad questions that we're asking. And it would be very useful, I imagine, to have more ongoing feedback from people who are in the process right now of working with data, developing code, and actually their experiences working with these tools so to help guide our thinking from kind of these very high-level scientific and policy-related questions to make sure that we're not missing any of these key things. I think we've had a bunch of good comments, throughout the session, but it'll be good to make sure that, both for here and for ongoing future meetings, that we make sure that we're getting pretty rapid feedback from people who these decisions will be affecting at that level. And so just wanted to put that out there.
Thanks, Josh, and thanks, Brianna, too, for that insight. So we have about 5 more minutes. So is there anyone online or anyone in the room who would like to comment or ask a question?
I'm online. I'm Alexei Krabrov. If I can mention actually very similarly aligned initiatives for open science, not actually realize that one such exists, but it's a generic term. So what we're focusing on is bringing together scientists working on open source in all disciplines, right? Not just geophysical science, astronomy, but actually whole broad set of disciplines. And so the questions are essentially community building, prioritization, and mapping of all open source to their respective sites. So I think the DOI discussion is very relevant because you need ontologies of sciences to map different kinds of open source projects to them. So I just wanted to generally mention this. The URL for our effort is opensource.science. It mentions several activities, so I'm very happy to hear all of the topics here. I think online repositories, ontologies, so this is all extremely relevant, and I will be reaching out to a lot of folks here to basically engage. And so the initiative is at NumFocus, right? NumFocus is the home of Notebook, of Jupyter and Pandas. So we structure it as an activity around open source projects, such as NumPy and SciPy and so forth. So, and I think a lot of them are actually astronomy related. So generally, very happy to connect with you guys. There is a newsletter at this site. It's a Medium blog, and so you can sign up and be in touch. And I'll be definitely, learning more about NASA initiatives and communities.
Thanks, Alexei. It looks like we have a hand up from Aaron Roberts.
Yes. Hi. I just had one general comment that I want to make sure that we keep open about solutions and not have top-down solutions or things that are imposed without consulting in the trenches. I know there's sort of general chit-chat that it feels like sometimes people are kind of trying to adopt a general solution to a problem, and it doesn't fit everyone. So we want to make sure that we keep and particularly the smaller, I mean, heliophysics is somewhat smaller than, for instance, earth science, but we want to make sure that the individual voices are still kept to the fore, and that everybody has the ability to opt out in some cases to maintain the services that they have.
Thank you, Aaron. Yes. Oh, Steve, did you look like you had something? Oh, okay. Yeah, thank you. Thank you. Yeah, sure.
I just want to, this is Steve Crawford at the with the Chief Science Data Office, and I think there has been several comments, and the last one to recognize Aaron's comment there of our interest in one of our core values is that do no harm, and to we know you and our data repositories are doing a fantastic job of making their data available to our communities. What we really want to do is provide you with more capabilities, and so you can even focus even further on providing value for our scientific communities. And so if there's some point where we're doing harm, where we're putting at risk that making our data available, let us know as soon as possible, because that's when we do want to hear from you. We do want to hear from that, and we don't want to. That's opposite of our values in looking how we're going forward, and we do want to be working with you in developing these solutions.
Thanks, Steve. So I think it's time to wrap up and take a break. Thank you, everybody, for the discussion. It was a really good discussion. We're going to come back at 11 for a further breakout session. So,
and you can pick anyone at random to join, and then have a chance to have a smaller group conversation. And the links into the breakout rooms you should be able to see in the
data management and all that. So yeah, maybe we'll get a chance to talk a little bit more after as well.
Great.
Yeah. And then
my name's Hannah Coverly. I am with Booz Allen, and I've been supporting the data and computing architecture study workshops that have been ongoing.
On the upper right of the participant panel, there should be a link to the different breakouts.
And I hope that others are also walking away from this meeting with a similar impression, because I came into this meeting not only not being able to fully say the title of the office. I think that's happened on multiple times. I now got it, but I think at a deeper level, not appreciating what the office could do, and I think that that's critical. And I really hope that the office pushes hard in this direction. On the not so good side, I would along the lines with what Alberta was saying, but with a little bit of a take, is that there are
we'll put them into the Jamboard. We can try to get them sorted out, but it's probably easier if we can collect up words, maybe in bullet format in that Google document. Joshua Peak, please.
Hi, sorry for being here, chatty Cathy all the time, but I wanted to answer this question in particular because I always
on the wall approach at this point. I don't believe we fully understand what we need to do to tackle open science. We don't even have a uniform definition.
Trying to see if
Well, now we officially have more facilitators than we have participants.
Would Christian, are you or Cindy, are you suggesting we just join a different group?
Cindy, that's what I was thinking. What's your
at a strategic statement that folks can understand. And of course, we're going to continue to interpret that in a variety of ways. But I think, again, by having this office here that can bring us together periodically and fairly frequently, we will all talk ourselves into an agreement. And that's what we should be doing, right? So I think we're really suffering. I see how we're really siloed from each other, and I think one of the, also back to the positive, I come away from this meeting energized. I come away from this meeting seeing what our peers are doing in the other domains, feeling hungry to talk with them, to adopt many of their solutions, and to accelerate our own approach to open science. So I just want to end here by saying thank you for hosting this meeting.
Thank you for the comment, Brian. We'll have one more comment by Jordan, and then we'll go to the next question.
Flopping a little bit to actually say anything. So yeah, I think the one thing that the effort specifically that Kaylin's doing, which is within this whole realm of openness and trying to share metadata, and specifically the semantics and ontologies and things that the data catalog effort, right? And how we can share that across the domains, I think is critical to driving the whole, the SMD strategy, everything that we're doing. Because at a high level, there is that consistency and that drives everything below it, right? And if we can start using the similar language, using the similar way we're describing our data and information, at least at a high level, linking all that together is critical to making sure that we're using this data the right way, right? And for the community's purpose to be able to link across. So I think that is a huge effort that's seems impossibly hard to find where there's that consistency. But I think that the fact that that's moving forward, even if it is maybe not working right now, the search and stuff like that, I think at least marching forward and pushing it, I think is huge to enabling all the other efforts that we're trying to do.
Thank you, Jordan.
Excuse me. What is Jordan's last name?
What's that?
What is Jordan's last name?
Padams? Jordan
Thank
Padams.
you.
And Brian Thomas
Hi.
was the previous speaker.
Yes, I got Brian's name. Everyone, if you wouldn't mind saying your first and last name when you begin speaking. I've gotten multiple asks for these notes today, so I want to make sure that they are clear. Thank you.
Yeah, I think both of the comments have also touched on a little bit on how we can advance the implementation of our open science vision. And it's great to hear Brian has definitely identified areas for collaboration. But do others have thoughts on this? And
Hi, this is Brianna Pagan. A bit piggybacking off what Jordan's saying. Obviously, we have all different domains, different applications, but it would be nice to get unified architectures for the things that we're doing, right? We can all get around metadata or ingesting data, having to publish data, and I think we lack guidance on architectural components of that. So how do we all validate data? It doesn't matter what the data is. And I mean going exactly into like what type of softwares and things like that. So yeah, that would be my suggestion.
I absolutely second that. Thank you for bringing that up. That's what my thought as well. I think what we want to think about is, I'm sorry, Emily Law, L-A-W, last name, I'm from JPL. So what I'm thinking of, from the open data standpoint is the entire data life cycle, from where we create the data, generate data, acquire the data, all the way to management, and then to be able to share and use the data. So I think we can look at each of this component, look at the architecture and say what we are doing well today and what is it that each component is supporting the open science or not, and look at really the gaps. And so maybe as a community, we can address those gaps. I totally agree with Walter and Brian's, the takeaways. This is a great meetings. I was actually wondering, have we, based on all this input, come up with a list of things that we need to address? That is not clear to me. I mean, absolutely, the metadata thing is one of them. The architecture thing is another. So if we can just look across the data life cycle from that standpoint, potentially that will help us come up with that kind of gap analysis in the list. Thanks. A great meeting, by the way.
Thank you very much, Emily. Yeah, so we'll have a quick response by Mark, then I'll go Marshall, and then back to Brian.
Mark Parsons, UAH. Short answer is yes, or at least for day 2. My plan next week, day 2, you know, we had the 8 breakouts or whatever for a fairly long time, produced tons of content. My goal is to go through that and start identifying common issues and start prioritizing them, bringing them back to the guidelines working group and thinking about where do we go next with this. And I think there's probably a need to do that probably across the whole workshop. And so it's like Brian said, the CSDO now has a lot of work to do.
This is Marshall Stuczynski from JPL, and speaking to the question that we're trying to address here, generally not necessarily piggybacking off the previous discussion, my thoughts on advancing implementation of open science is really that we need to rely on two-way communication between the Chief Science Data Office and people who are using and creating and administering things relating to data repositories. And as a user, I have a self-serving interest in that I think that I am one among many that can help us benefit from being embedded within the scientific community and being strong proponents. I think that we need more people like myself who are being asked to share the good word and help persuade others to openly share their science.
Thank you, Marshall. We'll go Brian, then Mo.
Hi, Brian Thomas, Heliophysics. First of all, I'd like to 1+ what Marshall just said about two-way communication. I think that's really critical for us to move together well. I'd like to respond to some comments about a unified architecture. I don't want to see that as a primary deliverable of this office. I think that unified architectures come out of very deep technical problems. I think that the office can facilitate technical discussions and drawing the community together, but it's not always possible. And let's just pick on metadata. And I say this as someone who has been a system architect for a scientific archive with many instruments and has worked with the ADS and is working with the ADS. And there are metadata can be brought together at a very high level, but once you start getting down into the use cases of how things are done within that domain of science, you immediately start running into problems. Problems in the way it's organized, problems in the definitions. I'll stop with a very simple example between heliophysics and earth science, which is one of my favorite hobby horses, and that is the term granule. It means something particular. It's a type of data set in earth science, and in heliophysics, that's a feature on the sun. And so we will never come to an agreement as to what a granule is, and therefore we cannot have uniform metadata. That's just an example. I can think of many more. So no, let's not have a driver towards it. We will spend so many fruitless hours and days and years trying to come up with a unified architecture, and it's not the first most important thing we need to do. Thank you.
Really quick, I'm just going to respond. This is Brianne again, because I agree with you, and that's not what I meant. Is like, let's implement a unified metadata. That would never happen. It's just the fact we all agree that we need metadata, so we need a system to support metadata. My example that I'm thinking of is regression testing. We all need regression tests, and I have no idea where to start conceptually. You know, are we going to test all data sets? So it's just general guidance of, if you're going to ingest data, how do I do it? What packages out there can you leverage? So anyway, I agree with you on not being that literal on.
Okay,
yeah.
okay, so I would agree with that. So I'm very happy that we had this little mini discussion. And I think, yeah, okay, so as a system architect, I think at a very technical level,
Yeah.
and Yeah, so
one abstract, one
so
level.
I think that's another thing is why we need to talk is because semantics can trip us up and create needless arguments. I have mastered that many times in the past.
Mo?
Yeah, this is Mo Kayat, NASA Goddard. This dialogue was actually excellent because it showed at the technical level, we are very good at solving issues and problems. Since NASA headquarters people are here and this is a NASA workshop, I also wanted to make sure that we are paying attention to that. There are a lot of non-technical issues, policies, and others that kind of hamper open science. I'm actually quite envious of some of my colleagues at the universities because they can practice open science more openly than, for example, us at federal facilities can. And I can go down examples of some of these things that hamper. I mean, my team, for example, just tried to create an open GitHub of some kind for us putting stuff in. And very quickly, we ran into issues and problems just because we are located at a federal facility. If we were just 20 minutes down the road at the University of Maryland, for example, this would not be a problem for us. So I'd like to also put on the board there that there is non-technical policy matters that need to be considered at an agency level to resolve access to open science. Thank you.
Thank you very much, Mo. I'll move on to the next question. And whether or not, I think we had some really great discussions yesterday. And we'll definitely be taking a lot from the conversations yesterday. But if anyone had some kind of any reflections or thoughts they want to share on increasing accessibility and equitable access to our data.
Matt Tiscarino, PDS Ringman Systems node. I just want to maybe make a sticky note out of the comment I made in the last section about documentation and user services.
This is Marshall Stachinsky from JPL, and speaking to the question on the slide, keep it free.
Sure. I'm going to go with Jordan first. Everyone gets a first comment before Brian.
Jordan Padams, PDS engineering node. So one of the conversations we had yesterday that was interesting was the fact that we as NASA don't do a good job listening to the community. I think, yeah, we don't do a good job listening to the community. We tell them or show them what we have and we try to support them or outreach, but like community forums or roundtables or something like that, where I think would be really an interesting way to understand the unreached communities or the communities that we can't seem to hold on to, right? In terms of our outreach. I thought that was a phenomenal idea. And I think that's something that should be raised up and something that should really be considered as an actionable thing to listen to find out why we're losing people that we get in internships and then, or they come to our booths and we talk to them about what we're doing and then are like, sounds good. And then we never see them again. I thought that was a really interesting eye-opening thing for me. So,
yeah. Jay, so is thanking Jordan for listening. Why don't we go Brian, then Josh?
Well, actually, I don't think Josh has commented in this session.
Yes. All right. So, yep. Josh, come on up.
So this is Joshua Pepper, NASA headquarters in APD. I want to make what might be a provocative statement, but I think we're all kind of like deep in thinking about this here. When we talk about accessibility and inclusivity, that in order to do that generally requires work. Usually requires making changes or building tools or services to make data more accessible. And I think that is absolutely necessary to make that a core approach to what we're doing with that. But I think it's probably necessary to realize that sometimes making data more accessible involves trade-offs, as in order to make data more accessible, sometimes it requires more stumbling blocks or more intermediate steps to ensure that all the people who want to access that data have that ability. And I think it's at least just worth keeping in mind that there sometimes are trade-offs when it comes to trying to accomplish what we're trying to do with making data more open, more accessible, and more inclusive. Sometimes the trade-offs are in funding. Sometimes they're in FTEs and person power. Sometimes they're trade-offs in the range of features that we're able to offer. And while I don't think that should keep us from trying to reach these goals, it does exist, and I think the people who operate repositories are very aware of that these things involve trade-offs. And when we talk about them at the high-level policy level, I think we need to be conscious of that, not to ignore the fact that trade-offs can sometimes be involved, and to articulate, what if there is a trade-off to do, like we can make this set of data more inclusive, but that or more accessible, but then that means that we won't be able to offer as many capabilities, say, to work with it. Then to grapple with that, and I think sometimes we have a tendency to maybe overlook the necessity of those trade-offs sometimes. So just as a comment to be aware of that and to make sure we keep talking about that as we move through this process.
Bree?
Yeah, this is Bree from LPDAC. I think one of the things that would really help more nascent communities that we're trying to reach is stability in funding instead of fleeting funding for outreach opportunities that have kind of a 2 to 3 year turnover. I think a stable presence that's available to come to when people are ready and slowly continues to gain traction and trust would be a really positive but somewhat long-term way to achieve some of the goals we're trying to achieve.
Okay. Brian?
I know you enjoyed that. Okay, so I want to magnify a couple of the previous points. Josh kind of stole a little more thunder. We'll have words later. But I think it's really critical is that inclusivity and accessibility are kind of amorphous, and they can be interpreted in a number of ways. And if we really want to make progress here, we need to define that a little better, because as Josh was saying, that could drive a great deal of resourcing. And it's not, and some of the things we're doing right now for other reasons are at odds with accessibility. For example, sometimes requiring a login for the data. And so I think it's really important that this office coordinate with the repositories and come to a more, maybe not a completely atomic list, but sort of some objectives in accessibility, some objectives in inclusivity. And obviously I think that I agree with the other comments that we should be intersecting with our user communities and to help define this. Because I can think of a number of ways that we can make our data more accessible. Speaking as an implementer, we're currently going through an exercise of funding reprocessing data so that it can be ML and science ready right out of the gate. So that's one accessibility thing, but that's a non-trivial cost. And we literally have petabytes that we could be reprocessing. And I could easily spend a huge fraction of our budget on just that. Is that worthwhile? Does that align with all of our strategic goals in accessibility? I don't know. So I really think it's great to have up there. I'm, just like, to mangle a metaphor, mother pie and applehood, everybody can get behind it, but it's not enough. If we really want to take action, we need a little more detail here. Thank you.
Great.
Pre-LPDAC, just also going in a slightly different direction with this in terms of accessibility and equitable access nationally in the United States, but also globally. I think the 2I2C instances and having kind of a sandbox play space for people, and potentially, people don't really, we're not always saying, hey, Google Earth Engine is doing something right because a lot of people can sign up for it, a lot of people can integrate data, and a lot of people can do what they're looking to do with different data sets. So I think we should look at that a little bit more and potentially see if maybe we can't be as equitable as we'd like to be. Can we at least kind of replicate some things that we know are working in a system where we can mostly guarantee trust in the data that we have, with it being checked correctly?
Then Mark has a comment, then I'll move on to the final question.
Well, I want to try and synthesize or highlight a few things that came out in the last several comments. Mark Parsons, sorry. So one, accessibility and inclusivity are very different things, actually. And when we're thinking about the budget impacts of these and the prioritization of these, Josh is absolutely right. Accessibility has these serious trade-offs. But when we're talking about inclusivity, Bree is absolutely right. It requires sustained commitment. Just to tell you a fun story, I've done some work with indigenous people of the Arctic, and the Inuit have an Inuktitut word for squirrel, and that's what they refer to the researchers, because they show up in the summer, they scurry around the tundra with no apparent purpose, and then they disappear in the winter. And so that is not sustained commitment. But they want to get the knowledge from the locals about how environmental change is occurring. So that is not sustained commitment, right? And so sustained commitment is actually sort of decades of inclusivity. It's not a 3-year grant. So I think in thinking about the funding and prioritization of these two things, you have to approach them with very different lenses, is I guess my point.
Thank you, Mark. And I'm pretty sure I'm going to make Jaitza nod when I say this is definitely a conversation that we're going to continue with the experts and those impacted by the accessibility and inclusion in our processes. So this is definitely a conversation we'll be continuing. Why don't we give everyone 5 minutes and we'll pull everyone back, Cindy? And so this morning's discussion, which was, I think, really fantastic as well. But is there some additional thoughts that anyone would like to add on either next steps for this meeting? So an opportunity to kind of, which we haven't discussed, or other future challenges that haven't been mentioned during this week that you like to make sure is are on our list. Anybody have thoughts about this meeting in the future or processes for us to engage and do better?
This is Bree from LPDAC. I really appreciate this meeting, and I think it's great. So I think we should continue doing it. I think we should continue being kind of introspective and open to different opinions and seeing what comes out of many smart, engaged people collectively thinking about something that's challenging. But I also think we should strive to include more voices from people who are, I think we should try to include more voices that would be helpful to this conversation where we can, but I also think we just keeping the door open to having these conversations on a regular basis is a really great start. So yeah, thanks for doing the meeting, and I really appreciate it.
Thank you. Ashima.
So I think one thing which came out loud and clear in this meeting is that there's no one size fits all. And so I think we need to get away from that, recognize where, it is good to have cross pollination and where it doesn't. So having, more discussions on this so that the next time we have narrowed down a little bit of this, cross-pollination stuff. Thank you.
Thank you, Hashima. Go ahead, Mark.
Mark Parsons. Yeah, I think it would be great to continue to meet regularly, include more voices. If this was an annual event, like Kevin said, that'd be great. But I think it would also be good to have smaller, more focused events, and they in person where possible and appropriate, but can also be done virtually. So, Brian mentioned a persistent identifier summit that we had a whole flurry of conversation around DOIs that just emerged. So I think if we can identify some of those more targeted topics as well, will help us maybe make some more progress.
Josh Pepper, NASA headquarters, APD. Just as a minor structural issue with the meeting, for future meetings, one thing that I think we saw here was that a lot of the conversations amongst participants were some of the richest, most valuable parts of this. And I guess I would suggest that maybe for future meetings, we build in more time for both Q&A and general discussions between almost every single talk, rather than have series of talks, even short talks, that then without the opportunity to do immediate feedback, because I think it's just an overwhelming amount of information. And so I'd really like to sort of build in a lot more interactivity rather than more, with less structure, more interactivity for future meetings.
Christina.
Christina Motzik Xavier, NASA Langley. So this hits on the topic of, a broader audience, a broader participant base, as well as thinking about communication a little bit more differently. We've heard a lot from folks who work at the DAC. We've heard with some researchers and implementers. We haven't heard a lot from projects and some of their challenges in understanding policies, the language and what it means, or even their communication with the providers at the DACs. And I think that's a key piece that I didn't hear a lot about and may help us talk about how to move forward differently or better.
Thank you. That's a great point.
Hi, Jordan Padams, PDS Engineering Node. I thought this meeting was great also, and to echo, yeah, I mean, some things can be fixed, like maybe some coffee, and I actually thought it was brilliant, though, was no plugs in the room. That was brilliant. You had to pay attention because your laptop dies at some point. But besides all that, the one thing I was thinking for reproducibility that I think is really a wide open question is we're encouraging the science community to put their software online and make it open, but there's really no guidance or specific guidance in terms of what does that software need to look like and or be documented in such a way that you can actually reproduce actually do reproducibility, right? I mean, it's better than nothing, totally agree, but I think we could do better in terms of providing guidance in terms of what does sufficient documentation or what the sufficient, even a GitHub repo, like what should be in there, right, with the software. And I think that's, the next step, right? I think anything is better than nothing, but I think the next step is it's less garbage if you at least have a little more documentation around it. So, yeah.
All right, I think we'll be having people come back in the room. I see there is some opinions. But one last question for the audience by the show of hands. How many people are interested in coming back next year? That looks great. Everyone but Christian. I think he wasn't paying attention. Thank you very much, everyone. I'm gonna and Cindy. Yeah, I mean, obviously Christian and we're gonna wrap up now. Are the breakout rooms closing? Okay. Hopefully everyone comes back in.
Emily Law, JPL. I just want to know that I know that you plan to make all those presentations available. Eventually, all these artifacts will be available. Would that be including what you plan to synthesize and then have a final report and whatnot?
Yeah, we're going to try and make all the information that we produce and as I said, a summary of kind of some of the things that have come out of the meeting. And we're following our open, our open science processes. We're going to make it all open. And so we'll probably also make sure that at least the overall meeting has a DOI. We will, make everything as available as we can.
Perfect, thanks. And I think that that synthesis of all these inputs you have is going to help you determine what could be the next steps.
Thank you. It may take us a little while. There has been a lot of inputs, and I know I'm going to be sleeping all weekend. So, all right. So welcome back to all the online people. It's nice to see some of you with your cameras on. Here comes Katie. We have, why don't we do, we had a little bit of time for a wrap up. I don't know if anyone who was in the online rooms wants to share anything from their discussions. We'll do maybe 10 minutes or so to allow people to share thoughts here, and then we'll have Katie Baines close out the meeting. And yeah, feel free to turn on your cameras so we can all see you. So
So I'll jump in. This is Bruce Wilson from the ORNL DAC. I was in online group 4. I think there was a consensus that this meeting was valuable. There is consensus for moving forward with something like this on at least an annual basis, although perhaps maybe shorter and with more focused topics. I think there was also a question about trying to make sure that we have a clear and relatively crisp definition of success. I think that was an area where folks maybe felt we didn't quite have that at this point. And then some other more specific answers to some of the questions that will take some digesting. Thanks.
thank you, Bruce. And thank you for, I believe that's Breakout 1 for their comments.
Steve, I can add to that also from our breakout session.
All right.
So we also had similar things that people really enjoyed the workshop. They were able to see kind of new tools that they may be able to use, learn from other repositories and systems, and also just have, great conversations with others about things that they have similar issues or kind of what other folks have figured out. So it was a great way to connect. To continue workshops like this, but I agree, maybe having more focused topics instead of kind of a long workshop with many ideas. And then the other thing, and I pose this back to SMD and all the folks here, was the question about kind of moving to the cloud makes us more open, and is that really required to be for open science? So to kind of continue assessing that with the community due to concerns of cost. So that was a question that was posed in our breakout session.
Thank you, Sam. Do any of the other breakout rooms want to report back? Okay, if anyone online would like to share their thoughts, please raise your hand. We'll give you a few moments. All right. Anybody in room want to share thoughts with the larger group? Oh, Isabella?
Since Shell did not do a plug, I will do a plug for everyone getting involved. At least sign up for the listserv for the Transformed Open Science Mission. We will be having similar conversations next week at our community panel. I'm sure people are feeling as exhausted as Steve and do not want to come to another virtual meeting that's a week long. But we will also be publishing our report out, which will focus on next year, 2023, as the year of open science, where we hope to be involved in a lot of the things that have been mentioned this weekend. So I'll drop a couple links in the chat in a second here, but hope to see some of these faces and voices in the conversations that TOPS will be hosting as well. Thank you, Cindy.
And Mike Little?
Hi, Steve. I just wanted to say thanks to everybody who has contributed. For those of you who heard my talk about the data and computing architecture study, we've gathered a huge amount of information, a lot of inputs from a lot of different people that we frankly wouldn't have found any other way other than through this workshop. So again, thank you very much for your contributions. I think it's going to really be helpful. Thanks again.
All right. I want to say, I'm just seeing if there's any other. All right. Well, I want to say a very big thank you to all of this morning's speakers, everyone who's contributed throughout the meeting. And I'm going to hand it over to Katie to close us off here.
It's the end. I promise to be brief, but maybe a little duplicative. And you get rewarded with pictures of dogs. But first, this classic, you know, this classic, this lady looking up at the heavens, so intense, so focused. Sorry, I'm a little punchy. It's the last day. Hey, oh, sorry. That's okay, I got this. Thank you. You made it to the end, like I said. Welcome to this. We're a little thin on the ground here, but I see some people have really joined us from their house who were previously here, yesterday. Hopefully they had, oh, no, I don't want to look for devices, stop. I just want to advance my slides. So as the Deputy Chief Science Data Officer, and you will get the acronym down, I promise. I've said it enough times. Part of the Open Source Science Initiative Program, the division leadership, and Langley, thanks for coming. Thanks for being open. Thanks for being honest and blunt and constructive and collaborative at the same time. And I just want to say that this is, it's been 4 years since last we met, as Jack reminded me, but it will not be 4 years before we tap you and invite you to collaborate with us going forward. So, yeah, you'll get sick of us. Well, hopefully not. So as we know, we just want to reiterate the goals. We wanted to receive feedback, open, honest, creative, constructive. We wanted to identify tangible activities, and I think that there's a lot of things, and we wanted to inform you of what we've been up to and help us improve what we've been up to and really try to engage you on what we're going to be building out. And really a big part of this was just to see each other face to face, learn new people, learn new ideas, build networks, and hopefully you're sort of feeling the commitment that we have to the process. And allowing us to be vulnerable with one another. So yeah, thanks. So we will be having a short survey because How are we going to know what we're doing, if we're doing better or well, if we don't measure it? We'll post the final agenda, links to all the talks, review and summarizing the discussions. Yes, so we've had note takers throughout all of this, capturing what's been going on in the chat, capturing what's been going on with all of the talks and the links, with all of the innumerable virtual sticky notes that we have created. And, you know, we'll continue this discussion, as I said. So really a reminder that we have the TWISC, as we call it in the lingo, F2. You know, we are looking for proposals that would be a continuation of this. So read the slide if you're looking at, you know, events, hackathons, training in open science. I encourage you to check that out. And of course, the TOPS folks want you to not forget about TOPS T. They want you to come to the Open Science Forum. That's happening a couple of weeks from now to ask questions. You know, they want you to have an NOI so they know how much there's going to be coming in. And with that December 8th proposal, you can go into the holiday season knowing that hopefully some money will come out the other side. All right. Now, this is where the dogs come in. So I really want to thank our local hosts, Christina and Tamika, and everyone at the Langley's, spelled incorrectly, facility. This has been a great place to have a meeting. We didn't leave, which is, you know, there's lots of nice places to walk around and things. So thank you so much. And I will not forget that this is a pretty good place to have a meeting. I want to thank our online facilitators and moderators, Isabella and the Booz Allen team, really making sure that, you know, and I know this has not been a perfect meeting, and I thank you all for participating with grace and patience. They have been working their butts off, as you probably know. And thank you to Shell and the people who wanted to come in person and weren't able to. I apologize for that too. This is a learning process. Like I said, sausage being made on the first day. Here we are on the other side. Hopefully we have some tasty links. Yeah, so great job, team. The next dog is for Cindy, and all of the people who volunteered their times and ran around with chickens with their heads cut off and moderated these activities. Great job to you all. Little praise hands, little claps. I see, Dana, you have your hand up, but I'm not going to let you talk yet. And then, you know, obviously, Steve, Mark, Kaylin, Elena, Shell, y'all put this all together so you get that cute dog with the glasses. Well done for organizing. And then last but not least, look at Christian over there. He obviously went to the gift shop, got himself a hat, and he's going to go home and just collapse. And so, you know, your tireless effort has not gone unnoticed. And we thank you so much. And I think that's it. One more thank you to all of you for actually coming and participating and engaging. And stay safe on your travels home. It is a little yucky out there. And I hope that everyone has made it through the severe storms and is making it home safe. And we look forward to continuing the conversation in the weeks, months, years, decades to come. So I think that's it. No more dogs. But I did see, Dana, that there are hands raised, so I don't know what to do about that. Oh, those were happy hands. Okay. Thanks all. Bye. Hope you beat the traffic.